This is Pre-Algebra Lesson 9-1, Introduction to Geometry, Points, Lines, and Planes. Geometry and geometric shapes are all around us. It is important that for this entire chapter, you understand the terminology for geometry, which means as I go through these words, make sure you are showing the examples that I'm showing, that I draw up on the board here. You need to copy those examples into your notebook. I've given you the definitions, but they won't do you much good if you don't have the pictures and the symbols that go with them. Now, there are three words in geometry that aren't really defined. They are more like explained, but they don't have a definitive definition. Those are point, line, and plane. A point is a location in space. It has no size or shape. It is simply a location. For us to understand it, we have to use something. So the symbol for a point is a dot, okay? And it's not a big dot, it's not a small dot, it's just a dot, okay? It has no size, so making it bigger or smaller does not change the point. The point is a location. It is where you are. It is always labeled with a capital block style letter, like A, or Q, or L. When we name a point, if you needed to name it, if I gave you these pictures and I said, please name these items, you'd have to use the word point and then put A, or point and then put Q to be able to name them. There's no symbol for point. A line is a series of points that extend forever in opposite directions. A line is labeled with two letters. Only two. It doesn't matter how many points are on the line, because the number of points on a line is infinite. Okay? It's normally labeled with two letters, both capital and block style. It is rarely labeled with a single lowercase letter. It's done like that when we add other things to the pictures. For example, if I wanted to show a line, this is an example of a line. That is a picture of a line. Okay, if I said, draw me an example of, it doesn't matter how many letters are on that line, it doesn't matter which direction the line is going, I could say this is P, Q, R, and S. A line is a series of, it's a straight arrangement of points. It's a point next to another point, because the points don't have size. It's just a bunch of points so close together they create a line. Its symbolic name, if you wanted to name it, you name it with only two letters. It doesn't matter how many letters are on the line. But if I have AB here, I need to know that it's a line, so we give the line symbol above the letters. Line AB and BA are the same line. Okay, these are exactly the same line. It doesn't matter what order the letters come in. In my second picture here, I can use any 2 points and they're naming the exact same line. I could use P and Q, and that's the same as P and S, which is also the same as S and Q. All of these name the same line because it goes forever in 2 different directions. So if I start at P and go forever to the right, and I'm going from Q and going forever to the left, it's going to overlap those other points as well. A plane is a flat surface that extends forever in all directions. It has no thickness. A plane is labeled with either 4 capital block letters, normally the corners, or a single capital block letter. Okay, for example, if I was to draw a plane, and I'm just going to make it really easy here by drawing a plane like this. Okay, here's my plane. I move my plane. There we go. This is a plane. If I wanted to make sure I labeled it as a plane, I might go P, Q, R, and S. This is a plane. That's a picture of a plane. I would name it plane P, Q, R, S. You have to label it with the 4 letters. You must go in order, either clockwise or counterclockwise. Start with a letter and go around in a circle one direction or the other. I could not call this plane QSRP because Q is not connected to S. Another way of naming this plane is just naming it with a total with one capital block style letter, normally in the corner, so we could label it plain T. Okay, so we could label this also as plain T. Not very often is it labeled that way, but sometimes it is. Now we can get into the words that we can actually define. Okay? A line segment is a part of a line. It has two endpoints. It has a beginning and it has an ending. A definite beginning and a definite ending. A line segment is named by its endpoints and you use two capital block style letters. When you were young and your teachers told you to line up, they've been telling you wrong all this time because you're never lining up because a line has no beginning and no end. You are actually line segmenting up because a line segment has a beginning and an end. It just sounds really stupid to tell you to line segment up. Okay, so if I have a line segment, okay, if I have a line segment, it goes, let's say I call this ST. That's an example of a line segment. Has a beginning, has an ending. Starts at S, ends at T. Or starts at T and ends at S. It doesn't matter, that's the same line segment, either one. To tell the difference between a line and a line segment, we use the line segment symbol, which does not have arrowheads on the top. Now, if I put more points on my line segment, I could have different line segments. I can even put line segments within a line. I have a line there, but I also have lots of line segments on that line. QL is a line segment. Okay. MD is a line segment. LD is a different line segment. QD is still yet a different line segment. All of those are line segments. None of those are lines because I did not use the line symbol. Okay. A ray is a part of a line that extends forever in a single direction. It has only one endpoint. A ray is always named by its endpoint first and then any other points on the ray. You still only label it with two letters. Okay? So a line segment is labeled with two letters. This is important. A ray is only two letters. A line is only two letters. Don't be adding extra letters you don't need. So I'm going to have a ray. There's a ray. Let's say it starts at A and goes to S. Okay? A to S would be a line segment, but A through S is a ray. How do I tell you the difference? You always start a ray with its endpoint. So the endpoint here is A. So I'm going to name my ray A. It goes through S, but I have to tell you it's a ray and not a line and not a line segment. So you have to put the ray symbol over it. A ray symbol is an arrowhead that always points to the right. It doesn't matter which direction my ray actually goes. I could have a ray that looks like this. N and O. The end point is O, so we have to start this, labeling this ray with O, and then we go to N, and it goes that way because you start with O and you go through N. We read from left to right, end point starts at the left, the ray goes to the right, so the line symbol goes to the right. Okay? To intersect means to cross. Okay? If something crosses, it means it intersects. Okay? So here is a line. We call this AB. Here is a second line. We'll call this line CB. And let's say they intersect at point P. Okay, they intersect at point P. There you go. Intersect at point P. Parallel lines, two or more lines that lie in the same plane and never intersect. They will never cross. Okay, two lines or more that lie on the same plane and never, ever, ever cross. Okay, I'm going to draw these even nicer. Let's see here. I'm going to use, never mind, I'm not going to use it because it doesn't want me to. Let's say we draw a line like this. And draw another line like this. These lines are parallel. Let's, for the sake of argument, we'll call them lines A and B and C and D. They will never cross because they're parallel. They stay the same distance apart all the time. If I wanted to tell you that line AB is parallel to line CB without actually having to write out all those words, I would tell you that line AB, it's a line, so I have to use a line symbol, is parallel. The symbol for parallel is what looks like two lowercase l's to CB. Okay? This right here is the symbol for parallel. When you are using symbology, that's the symbol for parallel. On my picture, if I want to show you something as parallel, I give it the same number of arrowheads through it. Okay, now I know that line AB is parallel to CB without having to write it out in words, because I showed you in pictures that they both have two little arrowheads going through them, which means that they are parallel. Okay. Skew. Skew is kind of hard to explain. Skew are two or more lines that do not lie in the same plane and do not intersect, but are also not parallel. Okay? If they are not on the same plane, you have to think three dimensions. For example, let me draw a picture of a box. And I'm not very good at drawing pictures of boxes, so you'll have to just bear with me here. If I was to label this box, okay, A, let's make this B, this is C, this is D, let's make this E, and this is F, and this is G. There are other points because it's three-dimensional, but I will tell you right now that AB is skew to CE because they will never cross. They're also not in the same plane. Because line segment AB here goes here, and line segment CE goes here, and since they're on different planes, they will never cross. On this two-dimensional piece of paper, they'll cross. But if you would use a Kleenex box and put a ruler one direction and a ruler the other direction, you'll notice they'll never cross. I'll show you that in class as well. All right, let's apply some of these things. Let's use the figure to name each of the following. We need to name 4 line segments that are different. And it doesn't matter which line segments we choose, just any 4. So, for part A here, I'm going to do 4 line segments. That means parts of lines. I could do like HO. I could do KO. I could do HJ. I could do IK. And I could do like OJ. It doesn't really matter. It's any of them that I want. Just make sure they don't repeat the same thing. Now I need 5 different rays. For part B here, I need 5 different rays. They can start at an endpoint and go any direction. Since all 4 of these have arrowheads on them, it doesn't matter where I start as long as I go through. So, different rays. So I'm going to say like OH. Oops, I have to leave it O first. Okay. OH is a ray, and it's different than ray OJ, which is different from ray JH, because J is different endpoints, okay, which is different from HJ, because they all have different endpoints, don't they? And I could do another one, so I could say KI. Okay, all of those are different rays. Now, let's look at this picture frame. Think of it as being three-dimensional. Okay, we have this lovely picture frame. We need, all right, think of it as, okay, this would be getting deep in. It's like a window box, think of. Okay, we need 4 segments that intersect PT. Intersect means cross. They will cross PT. So if PT is here, okay, we need 4 segments that are going to cross PT. So if you look at it, obviously, OP will cross PT. That's a segment. ST will cross PT. It's a segment. MP will cross PT. And QT will cross PT. So those are 4 different segments that cross PT. Now we need 3 segments that are parallel, which means they lie on the same plane, but they will never intersect with PT. Okay, so PT is the green line here that I'm looking at. I'm going to erase this little piece right there. So I need lines that are parallel, like MQ. MQ here is parallel, isn't it? So MQ is parallel. And if NQ is parallel, that means NR is parallel because NR is parallel to NQ. And you're like, well, that's only 2. I need 3 segments. Well, if you go over 1 more, you still have OS, don't you? So OS is also parallel to PT. Now the hard one. Let's go part C, which is skew. We need skew to PT, which means doesn't lie on the same plane. Okay? If it's not lying on the same plane, we have to think of this as being 3-dimensional. This is like a box, and this is the going deep in. R to S goes through the box deep-wise. So R to S is a skew segment because it's not on the same plane and it's not going to cross, which means also O to N is a skew segment, isn't it? Okay, O to N is also skew. When we look at this, we go, Q to R is the back part of the picture frame, so it's not going to go through it either. And if you have to, just pick up a box and think of the different pieces of this, and this would probably help. And if QR is, then MN is also. Okay. I will show you a picture 3-dimensionally of skew when you get to class, and I think you'll probably understand it slightly better. But this is the introduction to geometry. My suggestion would be go over your vocabulary, make sure you understand it, because everything hinges on these vocabulary words. You need to know what they are. So every night you should probably review your vocabulary at least once or twice. Go through them, read them out loud, so that you can get a good grasp on what your vocabulary words are.